Welcome to Computer Vision Streams. I'm your host Anton, and we continue to explore Yolo object detection module integration to DeepStream. And today we will see half precision optimization. In the previous episode, we deployed FP floating point 32 model of Yolo object detection model with image size 2 times bigger than in this table. Let's see what was the performance of this model. So we have a simple pipeline that will take a sample video. We will infer it with NVIDIA plugin, and we will use our FP32 model. Afterwards, we will measure FPS, output bounding boxes, and create the output window to visualize detections. You see that the detections are quite okay, and we observe 80 FPS for our model. Next, let's see the same model, but with a couple of modifications in configuration file that uses half precision model. Let's run this pipeline. So we see that the detection quality, at least from the first observation, is good enough, and we see that we have almost doubled the number of FPS. But here I found out that visualizing a Windows from the Docker container may take a couple of FPS, and if we will use the same inference pipeline but without drawing a window, we will see even greater performance boost, which goes up to 190 FPS. So with floating point 32 we had 80 FPS. With floating point 16 we had from 160 to 190 FPS. At least for vehicle detections and pedestrian detections, in my experience, I haven't seen any issues, and I always apply FP16 half precision modification by default. First, we already demonstrated that it could greatly boost the performance of the model, and sometimes even double number of FPS. And also another bonus is that the model size will be 2 times smaller, and accordingly the memory footprint in GPU will be 2 times smaller. For example, here we see that our FP16 engine is exactly 2 times smaller. Alright, so what should we do to be able to generate floating point 16 engine from our ONX file? So actually with DeepStream it's very simple. Our NVIDIA plugin could reduce our model to FP16 and perform additional modifications directly after 2 lines of change in configuration file. So first we will need to say to NVIDIA that our network mode is half precision, and give the name of our engine file. And then NVIDIA will take care of converting our ONX file to 1030 engine with half precision, and we can benefit with a great increase in performance. For classic architectures, I always observed very good performance improvements. Sometimes performance improvements could be limited because if we have some custom layers, or maybe some layers that are not very common and that does not support or have some issues with floating point 16. But in general, it's not the case, and all the classic computer vision models are greatly benefit from going to half precision. I hope this video was helpful, and it will greatly improve the performance of your algorithms. In the next video we will see how to push the performance even further, but we will play a little bit more with accuracy. Thanks for watching, subscribe to my channel, and I will see you in the next video.